Hello, everyone. This is Learning and Teaching, the CSSC event for spring 2022. Um, so learning and self-development is definitely something that defines us as humans and defines our intelligence. We do it on a daily basis, whether consciously or subconsciously. Yet we still have a lot of questions about it. And so to help us answer some of these questions, we've arranged this seminar and or talk, and we have 4 short talks from Dr. Armin Zare and Dr. Justin Koeln, who are both assistant professors at UTD. Brenda, who is an academic support coordinator at UTD, and Karthik Ganapathy, who is a teaching assistant. So following these short 10 to 15-minute talks, we'll have an open discussion and a Q&A. In the meantime, if you have any questions, please raise your hand. Otherwise, please keep your mic muted in favor of having a nice discussion. And with that being said, I will hand it over to Dr. Koeln, who will be starting the discussion. Dr. Koeln, the floor is yours.
Okay. Great, thank you very much. Let me start by sharing my screen.
We can see it.
Okay, great. So I'm more than happy to talk about anything regarding teaching and learning. I know the organizers of this event gave me a long list of potential topics to talk about, but I chose one that I thought would be fun to kick it off with, which is learning through play. And so I have just a few slides here to talk about this idea, give a personal example of when I found this very valuable, and just to advocate for this way of thinking, especially as we all get so busy, sometimes we forget to take time to play. And I think that this is actually a very important learning mechanism. So just a little bit about me. I'm an assistant professor in the mechanical engineering department here at UT-Dallas, where I joined in January 2018. I lead my research group in the area of energy systems and control. And so most of our research interests focus somewhere in the area of dynamic systems modeling and control, with most of our applications centered around thermal energy management. And our favorite control strategy is model predictive control. So a lot of our theoretical and applied research focuses around that. On the teaching side of things, I teach 2 undergraduate level courses in mechanical engineering, the Systems Dynamic Modeling Analysis course, as well as the Systems and Controls Lab. And then so far, I've taught a special topics course on model predictive control. And here are my 4 PhD students with one of the experimental systems in our group, or in our lab. So, as the title suggested, learning through play, I thought, I just start by kind of motivating this idea of why we should consider learning through play and what that kind of entails. And so when I started thinking about this and what I'd want to talk about in this short presentation, I asked a few questions, and these are purely questions. The answer could be no, but I think sometimes they could be yes. Where does learning require productivity? And I ask this question quite often when teaching my courses, because sometimes students, they wonder, why can't I just watch YouTube videos to learn this material? And my answer to that is typically because you haven't produced anything. And so how can you assess whether you've actually learned something or not? And I think production is a very important, but sometimes underappreciated part of learning. And then also, I think need-driven learning is at least the most effective or most efficient way of learning something. You can learn just for the sake of learning, but normally when there's a need, you end up learning what you need to know much more efficiently, and you end up remembering that more. And then, does learning require some type of intrinsic motivation? So all of these kind of questions are things I think about with my role as an instructor in the classroom. And I think the answer is yes to most of these, in the sense of, if you're in this intersection area where you don't require productivity, then how do you really evaluate if you've learned anything? So you need to produce something to assess, even yourself, self-assess whether you've learned something. If you're in this area here where you don't have a need, then how can you kind of choose or prioritize what to learn? How do you kind of know how to spend your time if it's not need-driven? And then finally, if you're not somewhat intrinsically motivated to do this learning, then you can probably do that for a short period of time, but is that really a sustainable learning process. And so that's where I think you might need all three of these, but there's probably obviously counterexamples. And then I thought play, this idea of play, kind of fit right at the intersection of all three of these things, or at least it can. And so when I started looking into this a little bit more rigorously, I saw that there's a nice definition here that play is defined as a non-serious variant of functional behavior. And so I think these functional behaviors are what we prioritize all the time in terms of doing well on exams, writing research papers, things like that. And so then play could be the non-serious variant of that. And there were actually some pretty well-defined criteria for what play actually is. And it should be self-guided, and that kind of gets into that intrinsic motivation aspect on the previous slide, where this should be something that no one's telling you to do, even though I'm kind of advocating for it right now, but that you want to do, right? That you're internally motivated to do. Play should also prioritize kind of the means over the ends, and what that kind of is saying that you should be enjoying the process. The process itself is what you're going for, and not just the end goal of that process. And then some aspect of it should be repeated or varied so that you can have this sense of practice, so you can kind of get better at it, but once again, you're kind of getting better at the process. And so I think this idea of play is very well studied in child development. So I just provided the most generic link on that as just a place to start. But then it's also being used in the area of robotics, and that's a little bit more relevant with one potential link to this from Google. And so then maybe the idea of play is an important element of learning that once again gets a little is not talked about as much. But so I want to give my own example, one that I did near the end of my PhD. So I got my PhD in December of 2016. So this was kind of, I think, during the summer of that year. And in a time where I should have been very busy, writing my dissertation and stuff like that, I kind of found time to play. And the project that I played with was I can't remember exactly when Sphero came out with these little robots, but if you're not familiar with these, it's a spherical robot where you have in this case, a clear outer shell, and then inside the robot has some wheels, and so it can basically create a torque and roll this ball around on the floor. And so I thought these were really quite neat. You can probably you can control them from your cell phone and things like that. And so then the natural idea was, well, what if we had a whole bunch of these? That would be kind of fun. You could do coordination control, and there's a lot of people even at UTD that have done these type of things, developing coordinated control strategies for a variety of robots, including Sphero robots. But what I hadn't seen is, what if you tried stacking them on top of each other? And this is what I just got curious about, and then I found time to play to kind of think through this idea a little bit more closely. So in this case, what I'm saying is that this one is in contact with the ground, and then this ball or this Sphero robot is balancing on top of the other. And so in this case, you actually have two actuators. You have, both of these spheres can create an internal torque to cause them to roll in certain directions. And so could you actually get them to balance on top of each other? And so it's kind of like an inverted pendulum problem, but where each link, I guess in this case, has its own actuation capabilities. And so then, that was kind of curious, and I was wondering, what all would be required for this to happen. You'd imagine that there'd have to be some friction between these so that they didn't slip and that type of stuff. But then, what's the limit? Could you have a stack of 6 or 10 of these rolling around and balancing on top of each other? And that's just, it's maybe a practical idea, maybe not, but it at least was fun. And that motivated me to start playing with this idea. And so when I started thinking about what would need to go into developing a system like that could balance vertically and be stable and roll around and things like that, well, I started thinking in 2Ds. Well, instead of a sphere, let's just model a disk, and what all the considerations you need to do to even be able to do this in simulation before trying to do it in the real world. And so I didn't have a whole lot of experience with rigid body dynamics and modeling collisions and rotations from torques and stuff like that. And so I started simulating these things, and I started with a 2D ball example and developed this using a combination of MATLAB and Simulink. And the first thing I had to do is figure out how to get these balls to collide with each other, how to get them to kind of bounce on the floor, and then eventually have those bouncing die off, and then have it be able to roll and all these type of things. And so this was kind of my first foray into all of this, and and it was just fun. I was coding and I liked coding. There's a visual aspect of that, so I liked that as well. And so I really was playing, but I was learning a lot about dynamic systems and controls and a lot of things that go into collision detection and stuff like that. Okay, and then I wanted to ask my question, if I were going to stack these, I don't want to have to pick up one ball and put it on top of the other. I want them to be able to stack themselves. So if they had two balls on the ground, could they roll in such a way that one could then climb on top of the other? And I had no idea if this would be possible. So once again, in 2D, I tried creating a simulation to see if this was the idea was possible. If two spheres of the, or sorry, in this case, two discs of the same diameter, if one could climb on top of the other. And so here I have them rolling at each other. This one starts rolling the other direction, and because of the friction in between them, they kind of, that one ball kind of bounced up. And in fact, it does get kind of on top of the other one. And I don't have a closed loop controller in here. This is all kind of open loop control actions, but it was at least a proof of concept in this kind of fun thought experiment that maybe with enough friction and enough torque, they could actually climb on top of each other. And then I stepped to the next part of this, which was answering, well, what if once they were on top of each other, would they be able to imbalance? Is this similar to an inverted pendulum on a cart or the BB-8 robot, that type of thing? And so then I started developing some closed loop controllers and just kind of demonstrating the idea that there was a kind of an unstable or stable limit cycle here, but yeah, there could be some control that would allow them to balance on top of each other. And I never got all the way to developing a really good controller, but this was at least a proof of concept. So anyways, that was just me having fun, but I learned so much in the area of dynamic system modeling, coding in MATLAB and Simulink, and eventually closed loop control that I felt like there were a lot of kind of tangible and intangible benefits that came out of it. So the outcomes were kind of transferable skills where things that I was learning because it was fun, then it could translate to my research, which was also fun, but it wasn't necessarily play. I developed unique experiences, and these are, I think, really important when you're looking for your next job or things like that during the interview process. Things that you could talk about that you just that make you smile during the interview because you just enjoyed it so much and you just had fun, and then can talk about all the details because you were the expert in that area. I think taking time out of your busy schedule to play definitely reduces stress and pressure. It's really nice to be working on something that doesn't need to change the world or doesn't need to create a whole new set of knowledge. You're doing it because you enjoy the process and just because you're having fun. It was also something that I was able to become an expert in and then teach. Friends of mine in my lab were asking me, how's the stacking disk project going on? And I could tell them about the different things I was learning. And once you're able to teach something, that really indicates that you've learned it well. And then it did really create a lot of motivation and context for me to learn more. If I were still taking classes, I would have loved to learn about nonlinear control strategies that would have been able to stabilize this disk. And so now all of a sudden I had this need to go and learn more from the different classes that I could have been taking. And so just kind of a quick summary here, while play can produce beneficial outcomes, while there could be a good outcome of this, the real goal here is to do something that you enjoy, do a process that you have fun. And so you can kind of think about this similar to a hobby where, the goal is to enjoy the time spent doing it. And that's what I'm trying to stress here. And then finally, this does get kind of serious. Lots of people recognize that play is an important part of learning. And so a great example from some friends and colleagues of mine that work at the Johns Hopkins Applied Physics Lab, they actually developed a version of chess called reconnaissance blind chess, where it's chess, but you can't see the other player's pieces. So there's like a fog and you can't see these other pieces, but each turn you can sense a 3x3 grid of the chessboard to see where potentially the pieces are in those 9 grids. And so then iteratively you would be able to learn more and more about the opponent's positions. And so APL leads this competition to be able to develop machine learning algorithms to play this chess game, and recently there were 60 teams from a whole variety of different companies and universities that went and played this. And the whole goal is to have fun, but also to advance machine learning decision making under uncertainty. And at APL, as an employee there, they actually can get paid to spend a certain number of hours each week working on this. And so in this case, they actually get paid to play, which is quite neat. Okay, so that's all I had. Of course, I'm happy to talk about anything else regarding teaching and learning, but that's something I wanted to share.
Thank you very much, Dr. Koeln, for this interesting talk about using play in learning.
Sure.
Dr. Zare, you're up next. The floor is yours.
Okay, thank you. Do you guys see my screen?
Yes.
Great. So I'm going to, I had no idea that Justin was going to talk about learning and play and their interplay, but I'm going to give a kind of a short presentation on some personal perspectives that kind of build on this last point that Justin made on having some intrinsic motivation for learning. And this is mainly coming out of my grievances and approaching and coming across people who very often underestimate their ability to learn and tell me that they're incapable of learning something or something is too difficult to learn, whether that's in the research or in a course that they're taking. So I wanted to kind of share some of my experiences throughout my education and how I have started viewing various things around learning and teaching and making sense out of these things and how I mentor my students. So to start off, I'd like to give a little bit of a background on where I'm coming from, and perhaps these things will make more sense if you know the person who is talking about them. So I did my undergrad and graduate studies all in electrical engineering. But when I started my graduate school studies at the University of Minnesota, I was charged with the task of coming up with reduced order models, control-oriented models for turbulent flows, complex dynamical systems that have very chaotic, complicated behavior, and their physics are governed by what is known the Navier-Stokes equations. But I, at the time, had no background in fluid mechanics. I had not even heard about the Navier-Stokes equations. And all of a sudden, I was being fed papers. Some of them were quite long. I remember that I honestly couldn't even finish 2 consecutive sentences without having 4 questions. So it very soon became extremely challenging to me to make progress, and it eventually took 2 years for me to start building a foundation in terms of understanding the physics behind what I was studying, and then gradually seeing the benefits of systems theory and optimization and control in a totally different area that was perhaps dominated for decades by people who were doing very large-scale numerical simulations and complicated experiments. During this journey, I learned many things. I took many classes, and these basically came out of my motivation to learn about the interesting physics of turbulent flows, and another more personal point in me just being a very stubborn person who doesn't take a no for an answer. And if I was charged with something, I was really going to go after it and get to the bottom of it. So during my time in grad school, I had to somehow overcome my shortcomings in terms of my knowledge of fluid mechanics, especially when I would go to conferences or even interacting with other colleagues that knew much, much more about fluid mechanics than I did. Eventually, I finished my PhD and I joined USC to be a postdoc. in, again, electrical engineering, and the task was kind of shifted at the time. At that time, I went into a postdoc with the intention of gaining independence from my mentors, my teachers, trying to kind of build off of some of the things that I had developed in my thesis and work on some problems that would later on form what I am doing in my research group today. But there was an added load of having to mentor and give advice and even teach some other students that were in the research group that I was working in. So another side of ultimately what became the same coin to me appeared and emerged as a side called teaching. And throughout my journey in grad school and postdoc, I eventually came to learn that learning and teaching were basically very close to each other. And if one could actually learn how to utilize one, it could benefit the other. And by learning and reviewing, you would become a better teacher. And by teaching repetition, you would be able to ingrain certain concepts that would perhaps come across as pretty heavy and complicated at first, much easier. So that would ultimately benefit your learning. But learning is difficult, and sometimes it's challenged by all sorts of things, including what's going on in the environment around us, any sort of ambient conditions, from the temperature, pollution levels, what day of the week it is, the time of the day, our social interactions, what we've had for dinner the previous night. These things can affect our mood, can affect our ability to learn. And what I often emphasize in interacting with my students or colleagues is that sometimes perhaps it's not a good time to learn about something. Sometimes it's better to put something off for a few hours or a day. And this comes down to us basically knowing or getting to know our body and our brain, ultimately, how our brain functions. And if we think about these things in deeper terms, perhaps with a bit of self-realization and a bit of knowledge about the science behind how the brain learns, we could facilitate and perhaps even alleviate the learning process. The brain is often compared to a sponge. It's analogous, and this analogy is perhaps something that you have heard of before when we talk about younger folks, younger people who are able to learn how to play musical instruments when they're really young, or how it becomes more and more difficult to pick up new languages as we grow older. Thinking about a sponge in even shorter time periods, well, we can come to certain conclusions about ourselves. Perhaps at certain points of the day or the week, our brain is too saturated to take in new information. Perhaps we need to give it a rest and sleep on something, and then reiterate and try to attempt to learn that material again. Just like any other part of the body, the brain needs to be fed. Apart from nutrition, it needs to be fed with material. The things that we read, hear, or watch during the day are the food for our brain. And if we don't exercise our brain and don't feed it over time, our brain is going to get lazy. So I often emphasize to the people around me, especially younger people, that it's really important that we all at least strive to read one scientific article outside of our field or tangential to our field every week. Try to challenge our brain and our ability to learn new things. And in this way, get out of the codes that we may not be working at the time, or the problems or the proofs that we may be stuck in, so that we can perhaps exercise other parts of the brain and develop some muscles that may ultimately come in handy in solving our own problems. It's very important to remain positive. And sometimes when we pick up a new concept to learn, say I pick up a new paper, I may just be overwhelmed by the number of new concepts that I would have to pick up. So it's important to not get discouraged. Certain techniques can be used to approach these sort of scenarios. For instance, one has to learn how to break up the material into smaller pieces, some of which may resemble things that we are more comfortable with, and start working our way through that material, and so that it doesn't look as overwhelming as it is in one shot. We have to be able to use all of the resources that are provided to us, that are around us. I often tell my own PhD students, my own master's students, you guys need to learn how to use me in an efficient way, because I, as your advisor, I am one of your resources. So we have to learn how to use all of the resources that are around us when we are stuck in a problem, when we are challenged with learning new things, and strive to see how every single resource may be useful in different situations. One of the things that we really need to learn to make better use of is perhaps the internet. There are tons of material on the internet, some of which may be correct, some of which may be wrong. But if we do enough search, enough reading, and develop a skill of searching the correct keywords on Google, then perhaps we will come across material that can facilitate our learning of the scientific concepts that we are faced with in our research. We often see these books that used to be published, I don't know if they're still around, called, say, Dummies in certain area. Say I want to learn about cryptocurrency for dummies, for instance. These days, you don't need to go look for that book that explains various concepts around, say, cryptocurrency or blockchain technology for people outside of that area. If you do a Google search with the correct keywords, you will come across so much material, so many blogs that have been written that can ultimately benefit your understanding, and in a sense, when the next time you come to the paper, to the main topic that you were trying to understand, you would see that information that you gained from that Google search would have benefited you and would alleviate your learning process. Last but not least, and perhaps even most important, is persistence, to not give up, to develop a sense of stubbornness and self-belief that we just ultimately don't take no for an answer, and not let anybody tell us that you can't do something. We have to believe in ourselves, keep pushing for some on certain material. It may take us a week to learn something, it may take us 2 weeks, but ultimately good things will happen with persistence if done in a methodical way, and if we use all of the resources that are around us. A few things that have worked for me in learning various concepts is to build my knowledge around causality, cause and effect of things. I would often try to form stories in my head of how various physical phenomena are formed, starting from the last piece of the puzzle, and see how that piece of the puzzle was connected to another piece and how that piece was connected to an earlier piece, and kind of building on the cause and effect of these things, I would form a story in my mind that would be much easier for me to understand and perhaps learn. These type of techniques obviously should be customized from person to person, but I have personally found building my knowledge on causality to be um, very beneficial, especially when you are diving into some material that may be foreign, completely foreign to you. It may be totally different from your own research and what you're comfortable with. Removing yourself from your comfort zone often comes with its challenges. And sometimes telling a story for yourself, and you may even see me talking to myself, and sometimes in explaining things to myself, can really benefit the learning process, and you'll be able to gradually grasp the important things. And along these lines, one thing that has really worked for me is something called concept maps that I'd like to share with you guys. And I've seen people in other areas make use of these things as well, especially when I was in high school and during my undergraduate years. I would draw these sort of maps in that basically are graphical tools that allow you to come up with an organization for these sort of cause and effect relationships that surround various building blocks that make up different physical phenomena. And these sort of trees that have different branches and leaves, which go by the name of concept maps, and actually entrain your brain to make use of the photographic memory, and even train yourself in not only memorizing the shape of these would alleviate your learning process, but it also helps you in developing these sort of stories that are easier to remember. Now, I don't do this anymore in my current situation, but to be honest, I feel like this strategy has been ingrained in my mind, and this is actually how I think about various things. In my head, I'm forming these concept maps as I'm learning new things, and even when I'm writing, say, a new paper, I try to organize my thought process by coming up with these sort of maps in my head, or if necessary, if need be, bring it on paper. And I'm including a link here in the presentation if somebody is interested in learning more about these things. Now, learning and teaching are very closely related, and the way that this happens is that ultimately by having to review a concept for somebody else and explaining the concept to another person, we are helping ourselves in developing a more mature understanding of that material. People who have taken courses with me may have noticed that one of the things that I encourage is in collaboration on doing homework assignments or even exams. I actually encourage people to work together, one for selfish benefits so that they would reduce the burden from my office hours, but on another level, what I'm actually trying to encourage is that people talk together and explain things to each other, because I have personally witnessed the benefits of discussing not only the things that I learn in my courses to my classmates, but also my research, various research topics that I was dealing with. So one thing that I would definitely try to promote is that we explain research topics to one another, to our lab mates, to the person sitting across the bullpen who may not even be in our area, even if what we are reading at the time, if we have not even finished reading the material that we're dealing with at the time, even if we have not fully understood that material, perhaps in explaining what we're doing at that point in time, we will not only allow another set of eyes and ears to listen on and perhaps think about our problem and help us in understanding what's going on in that field, but through repetition and trying to explain things to other people, we would develop a sense of eloquence and fluency in that material, and having to repeat it and explain it to another person. So definitely, I would encourage more discussions. I've noticed our students talking about social things and things outside of school to one another, but often I talk to them and I tell them perhaps what another student is doing and how it's related to their own research work, and I feel like they are totally oblivious. They don't know that the person sitting 10 meters away from them is working on a very similar problem. And to me, that's it's a um, just it's a pity, because we are spending so much time with each other in the research labs, and if we don't build on these sort of opportunities to interact with one another and talk about research in addition to other things, we would be missing out. And in a sense, it would actually help us in the learning process. So definitely learning through repetition and review would feed into teaching very well. It would not only make us more eloquent, better speakers, better teachers ultimately, but it would give us an opportunity to really understand the concepts that we're talking about as well. Now, on thinking deeper about teaching itself, we have to think, what does teaching require? Teaching is not for everyone. One thing that we have to understand is that nobody forces us to teach. I mean, not everybody needs to be a good teacher. Maybe we can learn and explain things to other people, but we don't want to become a professor or a teacher ultimately. You really have to have a sense of passion and need to change somebody else's life, to perhaps make a change in their attitudes and help them in their life to perhaps achieve things that they wouldn't be able to, in order for you to go after this profession. So a sense of a certain passion is required to become a good teacher. In addition to that, one needs to really believe in themselves. So if I don't believe in myself, in the sense that I don't have the power to make a change in another person's life or ingrain the material that I'm teaching into my students' minds and their thought processes, then perhaps I'm not going to be a good teacher. I have to first and foremost believe in myself, and then believe that my students can actually learn. And this requires effort. Something that I have come across is that people who really know material very well, they may even be experts in something, they don't put any effort in teaching and in making their presentations and thinking about the best way to explain something. In my opinion, that's again, it's a pity, because it's these are all lost opportunities for the people who are around us to learn from us and benefit from us. And one really needs to think deeply on what is the best way to convey knowledge. And in doing so, think about the audience and show some flexibility in changing and adapting, customizing your teaching teaching techniques and methods from one audience to the other. You have to train yourself to be flexible, sometimes even on the spot. When I teach, I have the tendency to look at my audience. I'm looking for feedback, and based on the feedback, based on the information that I am getting from sometimes just looking at their faces, I would have to on the spot show flexibility and repeat certain things in a different way. And if I have developed enough eloquence on explaining that material, then I would succeed in doing so, and eventually different people sitting in the audience, which may come from different backgrounds with different levels of understanding, will be able to be brought to the same level, and I would have succeeded in explaining that material. Getting feedback is obviously not only by staring at people's faces and looking for nods in the audience, and you have to show you have to be proactive about it, essentially. And it's often essential that we just go out of our way to ask people how we're doing and look for constructive criticism and how we can improve our teaching. So it's important to not only be flexible, but also to be up to date and improve and change our teaching styles from one semester to the other, and even from 1 week to the other, I would say. And this dynamic type of teaching skill set that we are developing would eventually hit on all of the learning outcomes that are required of a certain course. Finally, one thing that we should never forget is that teaching would never happen if we're not able to build a meaningful interaction with our students. We have to try to know our students, build some form of relationship with them, especially the ones that need us the most. It's when we get to know them, when we interact with them, is when we can diagnose the problem and try to help them in the best way possible in alleviating their learning process, in changing our teaching styles to best fit how they have been brought up or how they have been trained to learn. So that's all I wanted to share. I think it had quite a bit of different flavor from what Justin provided, but perhaps it would intrigue the audience and open some interesting discussions.
Thank you very much, Dr. Zare, on the interesting talk on the different ways we can improve our ability to learn and what it takes to be a good teacher. Yeah, we have one question in the chat. Rashi, you can go ahead and ask your question or type it in.
Professor, earlier you said that you used maps kind of thing, like in high school and everything. I understand that part, but how do we use those kind of maps now, the concept maps now? Like, I'm going to be graduating this semester with my bachelor's in mechanical engineering, but I was curious to know how we would be able to use those kind of maps now.
Yeah, so that's a very good question, and I mean the answer, I'm sure everybody, I mean when you think about it, throughout life we're always learning. So whether it's a simple, say, driving exam test that you would have to pass if you move to a different state after you graduate, or when you come across a different field and you're served with a different application, a different problem in which you would have to familiarize yourself with new concepts and some perhaps new physics that you may have not become familiar with during your graduate studies, you're going to have to learn. And these sort of maps, I'm not saying that you have to use these sort of maps. It's more a way, you could think of it as a way to facilitate the causality relationships that you would build between various concepts that could come one after each other, so that things would fall into place in your head and you could make sense out of how things work in the world and how to make sense out of things, to build a story for yourselves that you would be able to remember much easier. There is no such thing to me as like putting an effort to memorize something, because I know that if I can tell a story to myself, most probably I'm never going to forget that story. So if you're able to think about things in causal terms, as I explained, I think it can alleviate any kind of learning challenge that you would come across in the future.
Thank you, Professor.
Mm-hmm. Sure.
Since we are running out of time, I guess if we have any questions, we'll leave them to the end. And we can move on to the following presentation by Brenda. If you want to go ahead and share your screen, the floor is yours.
Okay, welcome. This can be very different from the previous two. So a little background on myself is my undergrad is in education. My master's was in counseling. And I worked 17 years being a teacher, and anywhere from elementary to high school, and spent 4 years overseas teaching at a missionary boarding school in Africa. So I come with a lot of teaching experience, but now I'm doing what I really love, and I work in the field of higher education in being a coordinator. I'm an academic support coordinator and academic advisor for the systems engineering department here at UTD. And I have been doing that for almost 7.5 years here. And then I worked 4 years in another university. And so this is a little bit of my, what I do every day is I work with my master's students. And so I'm going to give you some helpful resources for graduate students. So how do you know what to do and where to go? That is a common question from anywhere from your undergraduate to your master's to your PhD. You decide on a path, and then where do you go from there? How do you figure out what it is you really are passionate about and what you want to do? First of all, I always tell my students, there is a multitude of online learning platforms that you can utilize to dig in and figure out if you're even interested in something without having to pay a whole lot of money. That is always an issue with college students, is money. How do we fund this? How do we get money to do what we need to do? So Udemy, Udacity, Coursera, LinkedIn Learning, Google, all of these online platforms offer just opportunities for you to be able to go in and do some research and take a class that doesn't cost very much or very little. And as you move on in your career, it's a must, and you will always know that just because you graduate doesn't mean you're going to stop learning. So you are constantly learning, and you will always be adding to that learning and adding to your resources. I like to tell my students when they come into the program, I give them an empty toolbox. By the time they leave, they've got a bunch of tools in it, and they can use those to be able to become successful in whatever they're going to do. The other thing that you can do is know what options you have and what is best for you. You can listen to your friends. Everybody listens to their friends. However, keep in mind, you may be asking people who are in the very same position that you are, and they don't know what they're doing either, and they're giving you advice. So you can listen to what they're saying and to kind of take that in and then absorb it and then filter through it. Remember also, when you're asking for advice, a lot of times people are telling you what's good for them, what worked for them. That doesn't necessarily mean that it's going to work for you. So that's another thing that you have to figure out. What's going to be best for you? Talk to content experts. And by content experts, I mean professors, people who are working in the industry, alumni who have been working 1 to 2 years. Those are people who are working and who have the experience or have had the experience. And so utilizing those people is very important. Another thing, you may not know all the university resources. The university has so many resources, and I think half of the time, students do not have an idea of how many resources that the university has. There's several career centers. There's the career center for the entire school. It's particularly for ECS students. They have all kinds of resources. Most of the students that I deal with are in ECS, in the engineering, but they probably don't know that you can utilize career resources that are in JSOM, in the School of Management. They have a great website, and you just need to dig through it. A lot of times, you can't really, the appointments that they give and the things like that are for mainly their JSOM students, but you can utilize the resources that are there and they access them free. And also they do a lot of seminars and things like that. The library, another thing that I don't have on here is the library has all kinds of resources. If you talk to Matt Matoka, he has all kinds of resources that are utilized, and I think even more so for PhD students and what you need there. Another is the IPP office. It used to be called the IPP office. It's now called the Johnson School of Services. And that is basically for internships and jobs and things. And everybody can utilize that, the domestic students and international students. So that takes me to, I'm going to give you some internship job search tips. I deal with students all the time wanting to get internships and wanting to get jobs afterwards. I deal a lot with international students. Because I deal a lot with international students, I've kind of zoned in on a little bit more to how to help them be successful, because it is a very difficult process for international students. First thing I would tell you is settle in for the long haul. It definitely is not something for that's going to take. Some people get lucky and get it right away, apply a place and get in. Most people, rejections are a part of the process. Don't take it personal. If you start taking it personal, you'll never, ever apply for anything. Rejections are very normal. And so if you're getting all these rejections, then use it as a learning tool. Something you need to do or change is the reason you're not getting the interview or whatever. Sometimes the interview process can take months. Do your research on the companies. The most important thing you can do is know the company before you apply to them. Figure out whether it's a company you'd even like to work for. Figure out maybe what the work culture's like. Don't waste your time. I always say work smarter, not harder. If you're an international student, doing your research on companies that do provide sponsorship and pour your energies into that, because that is a challenge all in itself, is making sure that you're not spinning your wheels and wasting time. I've heard many international students say, well, I've put out 500 applications and I've got nothing. Well, then there's something that you're not doing right. Either you're not applying to the right thing, you don't have the right thing on your resume. There's many different ways and things that you can do to figure out why. Biggest thing you can do is network. Network. Get referrals. That's the best option. It's not what you know sometimes, it's who you know. Update your LinkedIn profile. Utilize that. Stay active on LinkedIn. Use that. And make your profile relevant. Use, as Dr. Armin said, use a story, create a story. A story is something people remember. You can spout out a bunch of facts to them, but if you do it in a story fashion, they're going to remember that. And that's what you need to do. You need to stand out. Have several versions of your resume. Tailor it to the job you're applying. If you use the same resume for everything, you are not going to be very successful. You have to tailor it to what you're going to be doing. And also, internships are a great way to explore opportunities. Once you get into an internship, you can network in there, you can get to know other team leads, you can get to know other aspects of the job, and you can explore and figure out what it is that you really love to do. And the last thing I wanted to talk about is once you get a job offer, what do you do? So many times there's somebody so excited about getting a job offer, they jump into it immediately and they sign the contract and it's a done deal. Well, let me tell you that if you may be interviewing for several different places, and if you have several different job offers, you want the opportunity to be able to choose what's going to fit you best, and maybe different companies offer different things. If you go ahead and sign the contract, then I will tell you it is not, and I repeat, not professional to go back and withdraw because you got an offer from another company. Okay, that doesn't look good on you. It doesn't look good on the university. So really think about what you're doing before you sign that contract. See how much time they give you before for a decision, and allow you to think about it or get a chance to get some other offers. Don't be so focused on the money or salary. I will tell you that will come over time, but if you're so focused on that, you may miss a great opportunity of growth in a company. So in thinking about the culture of the company, do you fit into it? How do you fit into it? Are people happy where they're at? Also figure out whether there's opportunities for you to grow and to be promoted. There is nothing worse than getting stuck in a dead-end place, especially if you're an international student. You kind of have to stick it out until you can get the right visa. So it's really important to think about things like this. And then if you have several jobs, you can potentially negotiate the offer. A lot of people do not realize that, and they go in and just settle. You have to think about, and you can get advice on how to negotiate with this. So these are just a few tips that I give my graduate students, and I hope that it was helpful for you guys.
Thank you very much, Brenda, on sharing some of the university resources and some of the tips on how to get a job and an internship, which ultimately helps in the process of learning and self-development. I guess last but not least, Karthik, you are up.
Hopefully you guys can see the slides.
Yes.
Okay, great. So hello, my name is Karthik, and compared to everybody else, my only qualification is I've spent more than 2/3 of my life in a school or in a classroom, and it pales in comparison to everything else which they've all got on me, and a lot which I want to say, they've already said it. So with that, let me get started on what I believe is my controls perspective of education. This is a controls seminar series. So of course you have to start with the control system, start with your environment, and you have your state space, the state of everything that you care about. You might be measuring it in some ways, and you might value the different components of it differently. And because it's part of the environment, there is some system of dynamics on which it's operating. Now you might care about where that state space goes specifically. So you try to choose some control systems. It's a sort of control that goes into it. You use information from the state space, you use information from the system dynamics, and you tune it best to go where you want to go. And things never stay ideal. So you've always got noise, which is there to bother everything and throw whatever your perspectives are off, slightly off skew. But education isn't any different. You're still living with this environment of learning and teaching. You care about how much you know about something. how much you know about something is influenced by how well you are learning it. How well you learn something is affected by how much guidance you get around you from teaching, from other people teaching you. And all of this is still affected by what's known and what's unknown. So with this perspective in mind, I like to talk about learning and teaching. This is an age-old idiom that you can lead a horse to the water, but you can't make it drink. In the end, learning starts and ends with you. Teaching is just a guidance that helps direct your path of learning. And the whole process of this involves setting a standard and measuring change with respect to where you are and what you want to achieve, and always aiming towards a specific goal. And the standards of what is learning and what is teaching starts blurring once you hit grad school and go beyond that. In all the way through school and through most of undergrad, you always have this very clear line between who's a student and who's a teacher. Once you hit grad school, you start learning from peers around you as well. And once you go to a job, you could be learning from people above you, below you, or even colleagues in the same level. But this thing of why is it learning versus teaching? There's this perspective of students competing against teachers. There's a sense of, are teachers supposed to be gatekeepers of knowledge? Do they get to decide, hey, you're good enough for me to teach you, or you're not worthy and I refuse to do so? Instead, how I picture this is teachers as ushers and librarians, where you've got massive art galleries and libraries full of knowledge, and you could choose to explore that however you choose to, but teachers are guides who are able to take you through different, who are able to map out part of that area for you, who are able to guide you through that process. And there's always the sense of, am I earning some value through learning? And am I being penalized for what mistakes I make? And moment you add value and remove value from something, this perspective of, hey, how do I quantify it in the first place? So quantifying knowledge. And the simplest way that we know about this is in terms of grades. There's always this perspective of the first day of class, hey teacher, are you curving grades over the semester? Hey teacher, is everything going to be absolutely graded this semester? And from the instructor's point of view, you always worry about, hey, does my class grades fit a specific distribution? You're always worried about this perspective of DFW. No, it's not Dallas Fort Worth. We're talking about people who have either dropped the course, who failed the course, who are withdrawn from the course. So what do all these perspectives matter? How soon do you start quantifying whether someone has learned something or not, what the standard is? Who sets the standard? Is there a way for you to go away from the standard? Is there a comfortable in between? While you're learning, it's always easier to learn without the pressure of, hey, if you go wrong here, something's actually going to go bad. And this perspective of, hey, are you starting from a blank slate? These many people like to walk into whenever they're faced with something new, they say, hey, I'm a blank slate, hit me with it. But a blank slate, while it seems clean, is actually quite messy to teach. There's always this, you always would like someone to have a perspective so you can discuss something with them rather than just inform them of something. You always like to have students who have an expectation of what they want to learn, and then you decide how their perspective changes. Part of it might end up breaking down every preconception that they had about something and then building up a new. Some of it might be tweaking and modifying minor errors or mistakes and so on. But a journey of 1,000 steps that involves a wide open, massive new field is always starts with a single step. It's this, Dr. Zare mentioned this idea of concept maps. It's this idea of adding a single new point to the map versus being introduced to a brand new field and expecting to immediately assimilate all of it. Doesn't work that easily. Whenever you're dealing with a network, it's always easier to add one new node at a time and see how things change, see how they connect. And the more connections you have, the better it gets. But if you have two completely separate maps and you expect them to be joined by one tiny link and expect to understand everything, it gets significantly harder. There's this quote by George Bernard Shaw about how science never solves problems without creating 10 more. How I like to view this is every time you answer a question and you open up, add one new node to your knowledge map, you should always be asking enough questions to think of 10 more new nodes which might connect to the same area. And this a lot of people look at knowledge as accumulation of new information. I like to think of knowledge as minimizing what you don't know. It's a permanent appreciation for, hey, there is so much in the world that you still don't know about. Now there's something slightly less which I still have to learn. uh, Another way in which I like to think about this stuff is, if there's a massive tree and you try to put your arms around it, every time you learn something more, you're able to get your hands just that much closer around it to put your hands just that much closer to touching. So now that we've talked about quantifying it on what matters, let's look at how we actually learn. And most of us have sat through enough number of classes, but there's always this thing of, how do we learn? What system works for you? How do you take notes, discussing concepts? I think this was something which both Dr. Zare and Dr. Koeln mentioned about discussing concepts with people who might be at the same level with you, discussing concepts with peers who might be well versed in the same field, with seniors in the same field, experts in the field. All of those give you multiple perspectives. Each one of that is just adding to your own value of how you view something. This could be something as simple as reading a paper by yourself, looking at a book by yourself, or in a group study, or like lab meetings in a research field, or bigger conferences and discussions, but all of those are part of it. And you're always playing a constant game of catch up. In my perspective, I spent most of my undergrad working with engine grease on my fingers, working on engines and cars and designing cars and off-road buggies. And it was only towards the very end of my end of my fourth year that it was even introduced to control systems. I felt like the last 5.5, 6 years I spent as part of my PhD program, I've been playing a constant game of catch up with the vast amount of information that I've been exposed to. And this is where it's important that you're self-conscious about your learning. It starts and ends with you, and you're the one who has to measure how well you've learned something. There's this term called metacognition, where you have to consciously mark off what you have learned, what is still open for you to learn, and how that fits into the broader framework of things. This isn't something which is very easily explained even after multiple years of sitting in a classroom, but is a very useful concept which, hey, as part of introducing the syllabus, if your instructor gives you check marks of, hey, if you're at this particular stage, if you've read the textbook, you should at least understand the terms which I'm talking about. If you've gone through a couple of example problems, you should be able to figure out how this theory works. If you've solved an entire homework set, you should be capable of identifying and solving these set of problems within the specific amount of time. And then you go sit in front of your test and you're set. And all of this brings in this idea of scheduling and time management. How much are you trying to jam pack yourself to do within a very short period of time? Are you trying to finish an entire semester's worth of course load 12 hours before your final exam? Are you spacing it out over the course of the entire semester? Are your homework assignments typically completed 5 minutes before they are due, 5 days before they are due, or 5 minutes after it's put up? And once you're actually comfortable with the field, it just becomes subconscious reminders once you go out into the world and you're exposed to different things. No one has to tell you when you look up a bill, when you walk into the grocery store and buy a couple of products that, hey, 1 + 1 is 2. I need to go back to what I learned all the way back in first grade or in kindergarten and think about how I need to add numbers, right? That just becomes it becomes a part of your subconscious. You're exposed to it in your everyday life. That's the point which you ultimately want to reach with anything new that you're dedicating yourself to learn. And there's this knife edge balance that you're working with when something is is something trivial, is something important, and is it challenging for me to learn, or is it exhausting to the point that, hey, this is too much for me to deal with? That's when the part that learning is, it starts and ends with you, but you can always get assistance. You should definitely get help if you need it. That's what teachers are there for. That's what TAs are there for. That's what academic administrators are there for. You should always be aware of help that is available for you if you need it. And now that we've talked about that, obviously the next connecting part is teaching as a guide. And this is a quote by Mark Twain, where college is basically a place where professors' lecture notes go to the students' lecture notes without passing through the brains of either. And how often, how just reading this, how many classes that you've sat in connect to this that easily? Your professor or your teacher is basically responsible for challenging you to learn and inspiring you to learn. This is a YouTube video of basically this professor walking up super exhausted before a classroom, but actually hyping himself up just to go in. This idea of the attitude with which you teach and with which you learn are super important. I'm not sure how high quality this is, but it's the first time I saw this video, it blew my mind. Basically, this perspective of, hey, your professors are kind of important. They are who you're learning from as well. So when your professor walks in, this is when you're teaching somebody, are you always just supposed to give them the right answer to a problem, or are you supposed to teach them to ask the right questions? I think Dr. Zare mentioned this about keywords when you're Googling something. How do you know what those keywords are? That's something which I believe as an instructor or as a professor, it's something that it's very helpful to build up appreciation for really early. Looking at simple keywords or looking at the black box bold text in your textbook and Googling that out might never be sufficient. And once you ask the right questions, you also need to build the skills to identify if the answers to it are right. You're exposed to the internet where anyone could say 1 + 1 is 3, but are you smart enough to identify that that might not always be the right answer? And there's this, when you're learning something, being unclear or being misunderstood is the hardest part, because once you subconsciously accept something as a solution, it's very hard to change it. So there's this thing in the workshops where you always measure twice and cut once, because it's very hard to cut something longer than it's been cut for. So the same thing applies even to teaching and learning. Check as many times as you want to, and then you just have to cut once. How in perspective of a classroom, this might be study, learn, and clarify mistakes or errors or misunderstandings as many times as you want before you hit an exam or a test. You shouldn't be experimenting on an exam. That shouldn't be your first time facing a concept. In terms of research, study the theory as much as you can, discuss with people before you go on to actually publishing research. You don't want to ever have a paper published only to come back with comments and reviews saying, this guy doesn't make any sense, it's all incorrect. And again, going back to what I mentioned a little earlier about timings and deadlines, set reasonable deadlines for yourself. It's impossible to achieve 6 months or an entire semester's worth of work within a day. But if it's something that you're consistently preparing for, it's definitely possible. And at the end of the day, your teacher is you as a teacher, and you learning from somebody. It's humans on both sides. You need to be able to accommodate for any kind of slips or mistakes or unexpected occurrences that might happen, which leads us to this idea of knowns and unknowns, or how I like to even expand it further is the known unknowns and the unknown unknowns. So when you're teaching somebody, are you trying to teach them a subject, or are you trying to teach a student or a classroom? The perspective of where your priority lies. Are you trying to broaden? Are you just trying to tell somebody that, hey, what I think is cool? Or are you trying to help somebody build their own perspectives and understanding about this? And when you go from a student to a classroom's perspective, how do you deal with an entire distribution? There might be some people, everybody comes from a different background. We have prerequisites in front of high-level courses, but how well do they actually meet those prerequisites? And this always, everything is unexpected. I think all the professors here can agree that you never have a classroom with 100% attendance over the course of the entire semester. Everyone has the sequence of grandmas and grandpas who are sick, or dogs who've ate the homework, or night out partying too late and ended up sleepy too late for class, to missed a deadline, late for a deadline. What do you do in all of those cases? The best that you can do is empathize, but how strict are you going to be about, hey, am I going to accommodate for these mistakes or misplaces or mishappenings? Or am I going to stick to my own sense of rigorous self-righteousness and 11:59 was your deadline, 11:59:01 is unacceptable. And this basically, you have to be able to build your sense of rules and regulations of what ifs, handling everything between an ink smear to a meteor landing in the middle of your classroom and disrupting everything. COVID, which has happened over the last 1.5 years, it's been very tiresome for education. It's changed the face of how we teach and learn. But hey, we need to teach, we need to learn. How do you deal with that? The end point of this being the human element. Numbers can fit everything from a grade to everything from a grade on a homework to the performance of a semester and the end of your undergraduate career or graduate career. It might decide your possible job opportunities, your ideas of scholarship and everything, but endpoint, it's human. The statistics over a classroom doesn't reflect the individual students that you're trying to deal with. You're trying to represent everything that someone might have learned over the course of a semester with a single letter or a single number. Sometimes you might need to go beyond that and look at who you're teaching and what you're trying to achieve with them. So just to conclude with all of this, like I mentioned multiple times, learning is an individual effort. You have to be capable of self-supporting yourself through it. And teaching is a guidance. Teaching is just guidance on everything, but it's valuable that you make use of whatever teaching and learning opportunities that you can get. And in the end, it's just an iterative process to perfection. So purpose matters. For me personally, I'm a very selfish learner and a selfish teacher. I'm selfish learning because I want to understand and find more cool stuff in the world, and selfish teaching because I can't bear keeping all of that stuff to myself. I want more people to also learn and appreciate the same thing so I can talk about it with them. So thank you for that. I hope this adds one more final twist to everything that was discussed today.
Thank you, Karthik, for the slightly more technical perspective and linking it to controls theory on learning and teaching. I guess with that, we have wrapped up the short talks. And we can open the floor to questions. So if anybody has a question, please feel free to type it in the chat or raise your hand and unmute yourself. So let's just give it a couple minutes. In the meantime, yeah, I guess the ideas of learning and teaching, there's, I guess, a lot of things were said in common. The idea of, using play to, and just having that internal motivation to learn, something that both Dr. Koeln and Dr. Zare talked about, as well as always being motivated. That is definitely one important thing. Yeah, I guess if you always preserve, you can put in enough time, you can always learn anything. But maybe one question that we don't answer as much is, so if we want to approach something and we feel a bigger burden of learning it, where do we draw the line between what is worth it to spend our time on and what is not? Like, where do we draw the line between let's spend X amount of time on learning this, no matter what that amount of time is, and where should we give up and look at something different? Anybody have any thoughts on this?
I don't think I quite enjoy the idea of give up. It's more of reprioritizing to find a different perspective, or you always a sense of how much value do you have to what you're learning. If you find something that might be more valuable to learn, you just end up refocusing. But I don't think there is anything which you could ever learn that has a negative value to it. It's always additive and accumulative, and you never know when something else might connect to what you know.
I think also just to comment on that, that aspect of need is good, right? That's what prioritizes us how to spend our time and what we should be learning. And I think that's also why the academic system is built on mentoring and advising. When you're new to a field, you won't know what to research. You won't know what the problems are. And if you were to not use your resources, if you were to approach this on your own, it would take years and years to be able to eventually get a whole enough, entire picture to be able to identify the gaps and the holes and where we need to go. And so I think that's where others, other people that you talk with, are resources to help you determine what to learn, and that shouldn't go unutilized. Yeah. For example, I met with a student recently who decided that maybe they didn't want to do research. They would rather do a course-based master's because they didn't know how to pick a research project. They didn't know what to go and learn and research. And that was disappointing to me because they didn't realize that that's kind of, as a professor, that's what our role is to help guide in the choice of that research project using our just head start, right? Our experience where we've been looking and playing in this field a bit longer. So I think, yeah, that can help in terms of determining what to learn and how much effort to put into learning something. That's where you can get feedback and advice from others.
I think it's also important to have focus in our lives, but never forget that the most successful people in the world are really broad as well in terms of their knowledge, in the sense that they can talk to very many people and have a broad skill sets and communications ability. And while we invest maybe 60% of the time on our own research field, things that are directly related to what we would be doing, perhaps it's worth investing 20 to 40% on things that are tangent to what we would use on a daily basis, just for the sake of familiarizing ourselves and keeping our minds engaged. Out of my own personal experience, when I was a PhD student, I would often get stuck on problems, and especially when I was coding, sometimes the codes wouldn't work. You would end up debugging for hours and hours, and it's sometimes important to just get out of that environment, pull yourself out of your of the essentially the hole that you've dug for yourself, and look at the world from the perspective of outsiders, and perhaps even find solutions for your own problems in an area that you may have not would have thought of.
Yeah, thank you very much for the interesting perspectives. I guess if there are no questions, we've also basically run out of time, so we can wrap it here. Thank you to our audience for joining us today, and thank you very much to our panelists, Dr. Zare, Dr. Koeln, Brenda, and Karthik, for telling us about their perspectives and giving us some tips about the whole idea of learning and teaching and all of that cycle. Yeah, and hopefully this was a very useful seminar to all the attendees. Thank you very much, and have a good rest of your day.
Bye-bye. Thank you.
Thank you, everybody. Have a good day.
Thank you.